Hi, Ritika.
Hey Mark, are we maybe on the wrong
Oh,
link?
no, we're not. I don't think so.
Slow day.
Yeah, well, here's
All right,
another
here we go.
person, Hartem. Um, yeah, I was almost ready to like usually if there isn't enough attendance by 5 minutes and I usually cancel this, but
Gotcha.
um yeah, I I
Yeah,
mean
so we're jumping
we
into
can
it.
proceed. We have a few things we can do. I just don't know if it's um,
Okay, yeah, we'll wait and see.
just give it a couple more minutes. Artem, remind me, please, what your interest in this area is.
So I actually trying, we just joined the consortium, like we
Hmm.
as a company Modelio.
Yeah.
And what we are doing, we're building a confidential cloud. Basically, we're trying to, to introduce a holistic solution to be able to run confidential workloads in the public cloud in a, in a confidential manner. So, very new to the consortium. So I'm joining the calls, trying to learn and explore the opportunities,
Hmm.
to see whenever it, fits our focus goal and then, to decide
Okay.
whenever to
I see.
how in there we can contribute. So right now I'm not precisely sure.
Yeah. Okay. Well, it makes sense to review the charter of this group because I believe, as do many others, that without integration with with the identity ecosystem for workloads, the uh, target market for confidential computing is going to be significantly smaller. So today, what happens is confidential computing can only work with encrypted data stores because basically what happens is the workload uses attestation to obtain a data decryption key, which means that any uh, relying party, any backend the workload works with, needs to provide it with encrypted data. But if you think about how today's applications work, like any kind of database, uh, basically relies on transport level encryption to uh, secure communications. It authenticates the client, and
Hmm.
then it serves the data in plain text. It receives requests in plain text. This is how GraphDB works. This is how Neo4j works. This is how MySQL works. This is how MongoDB works, right? So if you basically insist that any data store your confidential workload works with, must encrypt all its data before transmitting it to effectively application level encryption, that is a severe limitation. So what we're doing in this group is we're trying to basically say, can we say that a workload gets a workload identity that is as a result of attestation, and then it can effectively make transport level encryption the way it protects data that it receives and the data it sends back, and then effectively what this also allows is gradual uplift of your workloads to confidential without disrupting the entire ecosystem, right? So that's if you're doing confidential cloud, this is the type of thing that unlocks the possibilities, right? So uh, that is where there's a whole special interest group around that. So uh, anyway, I
And what is your current focus like? What are you trying to solve the active?
well, so the problem is so there are two problems in the standards communities. So we have two that we work with most closely. One is called WIMSI, one is called RATS, right? WIMSI is workload identity for multi-system environments. And in WIMSI, there is you should read the reference architecture, right? There is a node. The node is what attests. The node runs a multitude of workloads. All workloads trust the node. And then the agent runs on the node. Agent works with the server to procure credentials for all the workloads. As a result, the agent sees all the credentials. The agent can impersonate all the workloads running on the same node. And that's not how confidential computing is supposed to work. Under confidential computing, agent is part of the control plane. The agent is not trusted. Certainly, peer workloads are not trusted. So it's not like a workload can say to, yeah, agent, go ahead, you can impersonate me, and a peer workload might be able to steal my credentials and pretend to be me. Yeah, that's not secure. And under RATs, you perform remote attestation, you receive attestation results, and the attestation results is what you present to relying party, except the smallest change in your uh, workload measurements might give you different attestation results. And this means that all relying parties need to be in sync with what attestation results might get produced as a result of remote attestation. And as a result, it's not deployable. So you cannot deploy any change in any workload composition anywhere. You cannot update like a feature or fix a bug without chasing down every relying party that this workload might communicate with. So that's brittle. As a result, it's not deployable, it's not manageable at scale. So we're solving both of those problems in this working group by basically showing how you can obtain credentials. And again, this is all, have you seen our charters requirements and so on? Let me
No.
show, I'll point you. So, computing. So if you go to github.com confidential computing, let me share my screen so you see what I'm doing. That will help you come up to speed. Right. You should be able to see my screen now. So you go to this github.com/confidential computing. And then from there, you click on governance, I believe. And you click on SIGs. That's where all the special interest groups are located. And ours, so GRC is the other one. That's the one that's meeting tomorrow. I also chair that one. And this is TWI, Trustworthy Workload Identity. And then here, you see there is a charter document. So you can read about why we exist. There is a bunch of definitions in here, a bunch of goals. And then we have a separate document that's called Scenarios and Requirements. So that one is also a good document to read. This is a very detailed list of requirements that we're trying to satisfy and some notes. So yeah, I strongly suggest that you review these. Okay?
Yeah, we'll do. Thank you.
So, yeah. Okay. So what I've done, so this is effectively a subset of our reference architecture document. Let me stick the link into the chat as well.
Mark, is this the document that last week someone had asked for a review on from
Well,
members?
this is the one we're currently working on that
Okay.
it's a subset of our reference architecture that specifically focuses on horizontally scaling workloads. So Whimsy has this thing called a profile. So it's basically different ways of fitting inside the Whimsy reference architecture. I guess you can go and look online for various Whimsy profiles, but this is the one for trustworthy workload identity. Tomorrow, I'm meeting with one of the principals of Whimsy working group. He happens to live in Seattle, so for me, it's just a short drive. So I'm gonna talk about his view on this idea, and yeah. Anyway, so. What was I going to say? Yeah, I made a few changes over the last week. The major change is I've updated the swimline diagrams. So there's this tool called Mermaid, and in Mermaid, you write. There's kind of a markup language that basically, lets you do very detailed, annotations of what happens in a workflow. So yeah, so I updated the provisioning phase, specifically to put the wrapping key in here. So we decided that at the end of provisioning phase, the workload receives a credential and a wrapped credential key. And then the acquisition phase basically repeats step 15, last one here. See? The workload owner gives the workload a plain text credential and a wrap credential key. And then the credential acquisition phase is basically where I do not know why Mermaid didn't color these ones like workload owner, workload verifier, like it did in the other one, but whatever. And yeah, it's done it's basically explaining how the workload comes into the possession of the plain text credential key here in the final step. And what I did, I changed a bunch of wording and made a bunch of comments on the doc here just to make it clearer to the reader what we're trying to accomplish. And again, the link is in the doc, is in the chat. You can click on that. And if you don't have access, let me know. I can grant it pretty quickly. So yeah, that's what we did. And today, what I was hoping to accomplish is to uh, discuss with folks from, with more of a whimsy rats, whatever existing background, uh, my concerns here. And I guess if they're not here, we may just have to wrap up early. But I encourage you to read this doc, understand what it's doing. Feel free to put comments in if you have questions, if something is not clear, if you detect any kind of mistake. And I suppose we'll pick it up next week when hopefully more people can attend. Yeah.
Okay, I think I will go for the document. I send you a request, so being able to edit it also.
Let me take a look. I should be able to. I usually get it in my Gmail folder. I should be able to grant access to you right away before I forget. Yeah, I see that. Yep. You now have editor access. Should be able to read it. Okay.
Okay, got it. Thank you.
Margaret sent you a request as well.
Oh, you did?
I think there's also an option where you can just put comments.
Yeah, you can be a commenter or an editor. I mean, I don't mind you being an editor. You just, keep
Okay.
change tracking on so that I know what,
Right.
who changed what. There we go. I mean, now you both have access to it. Yep. All right, then I'll see you guys next week. And yeah, thank you for joining today.
Thanks,
Thank
Mark.
you.
I heard him.
Oh, Yogesh, hi.
Oh.
You're a few minutes late. We're just about to wrap up.
Oh, sorry about that.
Yeah, try to be on time next time. Otherwise, basically,
Yeah,
it's you might
no
risk.
worries. Yeah.
All
So
right.
you guys have worked on this document?
We haven't.
CW.
I was like Ritika and Artem, they're sort of new to this group, so I was
Okay.
mostly walking them through where we are, where all the documents are, what it takes to sort of come up to speed.
Yeah.
And the thing I wanted to do with you in the room today was well, like literally, I was just saying goodbye, saying, well, nobody showed up, so we're gonna like see you next week, and then like you literally
Yeah.
last minute you
Okay,
popped up.
no worries. That's fine. See you next week then, Mark.
Well, I mean, I
You.
did want to do one thing, and this is where I
Yeah.
wanted to get your so there is one particular concern I have in this whole thing that we were thinking about last week, uh, and that is the control plane is effectively orchestrating the creation of the credential and the delivery of the credential and the wrapped signing key to the workload. So all of that we discussed last week.
Yeah.
However, you need to be very careful in that the wrapping key itself, the one that encrypts the signing key,
Yeah.
must not be made available to the control plane that creates it,
Correct.
right? Because otherwise, well,
Yeah.
the
The
control
whole
plane
trust
is
model
really
falls apart. Yeah.
it's really not trusted, right? The control plane
Yeah.
is trusted in basically giving the workload an identity, but
Yeah.
it should not be able itself to impersonate that identity. And as a result, it should not have access to the signing key or the wrapping key of the signing key. right? So what I did here, and then you can review all the changes and all the comments. But and I also realized that's another realization. The credential acquisition phase. So the credential acquisition phase basically starts when the workload starts, and the workload already at that point will have received the plain text credential and the wrapped credential key, right? From that point on, there is only one set of steps that the workload does in order to update. So basically, it needs to generate its own asymmetric encryption key, or I call the key delivery key, and then it will attest and it will receive attestation results around the public portion of the credential key. And then with that, it can go to the key store. Right here on the right is a key store. And key store will validate attestation results, will encrypt the wrapping key to the encryption key and return the wrapping key. And then that's it. So there is only one acquisition phase. The acquisition phase is the same for all workloads. The provisioning phase, however, will probably be different. So there is one way of doing provisioning here, but then if you look at like how HashMesh does it, because HashMesh has this hierarchical store where a parent will give the child a wrapping key, or it will be derived in some way. So, there are probably several ways of arriving at the place where workload can start doing its own credential acquisition. So I asked Manu to perhaps write up his own way of doing like hash mesh uh, compatible way of doing provisioning. And then I wanted to also pick your brain to see is there going to be another way of doing provisioning that's compatible with this that I am not thinking about.
Okay.
Right. So that's maybe like homework. And you may not or may not know off the top of your head.
Okay.
Another thing I wanted to sort of walk through, and this is where one of my engineers is actually doing this prototyping right now, just to see if it's possible. But check this out. All right, so let's walk through this. So here we create a workload identity and associated claims, right? So that's the claims mapper basically decides, what the key release policy is, right? So basically, the workload owner understands what the measurements of the workload are, and basically understands, right? It understands how the key release policy would be based on the workload attestation results. So I cannot say to the key store, release the secret when you see these attestation results, or when you see these whatever measurements, without actually knowing ahead of time what those measurements would be.
Yeah.
And that's the job of the claims mapper. Actually, I think I made a mistake here. I closed that box early. So the claims mapper basically, it needs to understand both the workload measurements and what workload identity results, right? So I need to. There is a way to do that in Mermaid. To move this end over here. Come on. See what I just did? I encompassed the
Okay.
yeah. So anyway, so this wrong box. So this box now encompasses both 1 and 2. But so now we have that. We understand what the workload identity is going to be. We understand what attestation results would look like for that to get released. Okay. Now what I'm trying to do is basically trying to create a wrapping key and a signing key without the workload owner, the control plane, getting to know these things.
So actually, the workload's its own key will be created by workload itself, right?
Uh,
The one, because workload will not get the, or will the workload also get the key from key store in your model?
so there are 3 keys.
Yeah.
Okay. The first 2 are in the provisioning phase, and the last key is in the acquisition phase. In the provisioning phase, 2 keys are created. There is the credential key, the signing key. That signing key is asymmetric, and it's the one that corresponds to like the private key of a certificate.
Yeah.
Right. That's the key that you need that for proof of possession for the utilization of credential. That's the credential key.
Yeah.
That's key number one. Key number two is the wrapping key. That's probably a symmetric key. And that's
Okay.
the one that encrypts the signing key such that it can be given. So the wrapped version of the signing key can be given to the workload in plain text.
Okay.
So
Wrapped
those are the
version.
two keys. The
Yeah.
third key is this one. It's the asymmetric encryption key that allows the key store to deliver the unwrapped signing key into the workload securely. And that's the one that you attest in step 3 here.
Okay. Have we described these three distinction of the keys somewhere in the document?
Well, and not as a separate paragraph, but they're all mentioned individually. If you actually like, you can again. I very much welcome your review
Yeah.
to see if it
Yeah.
can be
I will
made
review it. Yeah. It
more.
can
So
be
it's
more
like,
crisp and
yeah,
clear.
in
Yeah.
this section we talk about, right? So the workload obtains the public portion of the workload credential as well as the wrapped private portion of the credential. And
Yeah.
then right, so it talks about it, but like it doesn't really say, look, there'll be 3 keys and these are the name of the keys and this is what they do. That may be a good section to have so that we can then refer to these keys.
Yeah.
uh you know so again, it's a draft. We'll improve it,
Yeah.
but
Yeah.
anyway,
Okay, I
so
will
let's
have a
just,
read of it thoroughly, and if I have any comments, I will definitely make the comments here on the document itself.
yeah.
Otherwise, I will drop an email to you with all the comments. Yeah.
Right. And then I guess we'll reconvene next week and try.
Yeah.
Basically, I would like to wrap this up as soon as possible because I decided, and I think we kind of all agreed, we're just not presenting this at Shenzhen.
Yeah. Okay. Okay. You agree
Right.
not to?
Because no, well, for one, few people are going to China. For another, it's going to be probably weird time hours. For a third, Whimsy already said that they're only picking up existing work.
Mm-hmm.
And Rats has its hands full. So, but we can do interim meetings on this, and we'll probably meet, like do a meeting and maybe some drafts for Vienna. But for
Okay.
now, I would like, I would like to have a presentable version of this for both Whimsy and Rats by end of February.
Oh, okay. Okay.
I think it's a reasonable goal because that gives us enough time to collect feedback and, continue working on it. Uh, and I'm meeting with Joe Salloway, who's one of the Whimsy principals here in Seattle tomorrow. So I'll
Okay.
talk
That's
to
good.
him about Whimsy profiles and everything
Yeah.
else.
So
But yeah,
that we need to someday marry this with the work done in Whimsy. Like this is some profile of Whimsy where your workload
that's
needs to be.
exactly, yes. That's why this document is what is even called the tri profile for Whimsy.
Yeah.
So I'll talk
And
to him about the details of it.
yeah, and once it is solidified, we need to create a ITF draft out of the cut down version of this thing, right?
Correct. And then
Yeah.
that's one we'll present in Vienna. But for now, I just want to put it through the interim meetings so people
Okay.
understand what's coming.
Okay, cool.
Yeah.
Okay.
Alrighty. In that case, I'll see you all next Tuesday. And yes, whatever review you can do, Yogesh, between now and then would be awesome.
Yeah, definitely. I will
All right.
review it. Yeah.
Thank you.
Cheers.
Okay.
Bye.
Bye-bye.
Thanks all. Bye.
Yeah. See you all.